Basic structure of an embedded system. So it has sensor, analog to digital converter, processor, ASIC, application specific integrated circuit, memory, D by A converter, and actuators. So sensor. So sensor it measure physical quantity and it converts an electrical signal. So that is called a sensor. So electronic instrument, analog to digital converter, a sensor stored the measured quantity to the memory. Then analog to digital converter. So analog to digital converter, it convert analog signal and sent by the sensor into a digital signal. You know what is analog, what is digital? So nature or my voice, image. So these are analog. For digital, it's a binary sequence, zeros and ones. The processor ASIC data to measure the output and store it to the memory. D by A converter, digital to analog converter. So, so after completion of processor, we have to convert digital to analog converter. So this between there is a memory is there. So memory, so it is like register, and finally actuators. It compare the output and given by digital to analog converter to the actual expected output stored in it. So processor in the system. The processor has two essential units. One is program flow control unit. Another one is execution unit. Program flow control unit. So this unit fetching the instruction from memory and implement the instruction and data transfer operation, data conversion. That means data conversion from one from to other. So these are the operations are done in program flow control unit. Then execution unit. So these are the things are included: ALU, arithmetic logic unit, program control task, data transfer instruction, halt, interrupt. So these instructions are even that sleep, reset. So these operations comes under execution unit. So the cycle fetch and execution instruction, the processor run the cycles and fetch and execute the instruction in same sequence as they fetched from the memory. So what are the various processor in the embedded system? So first, general purpose processor, GPP, microprocessor, microcontroller, embedded processor, digital signal processor, media processor. So application specific system processor, ASSP. So even these are the processor already there. Then we also have the processor application specific instruction processor, GPP core, then ASIC, application specific integrated circuit. So these and finally very large scale VLSI. So these are the processor available So based on that, how we can select the processor for embedded system? How we can select the process or processor? So system designer have to consider for selecting the process. The one is instruction set. Another one is the maximum bit. That is a 32-bit system, 64-bit system like that. So maximum bit, arithmetic logical operation. Then clock frequency. The processing speed depends upon the clock frequency. So what is MIBS? Million instruction per second. That means how many, how much instruction or a million instruction per second means how millions of instruction executed within a second. This MIBS. MIBS. Then processor ability to solve complex algorithm and meeting the deadline for their processing. So these are processor selection. So the designer have to consider for processing selection. So case studies. So instruction cycle time is 1 microsecond on chip devices and memory. So example, that automatic chocolate vending machine, robot data acquisition system. So these are, you know, that processor selection. For that processor selection, how they will be select. Instruction cycle time is 1 microsecond. So how which processor they have to select. Similarly, case study 2, 3, 4. Then memory devices. So memory devices that we will see in next video.